So let us start session. So yesterday started some basics. Yes, yesterday these basics were discussed, like what is software. Yes, software basically two categories: system software and application software. About system software and about application software discussed. So here OS comes under system software, application software. For the purpose of application development, Java is a application software. Applications like WhatsApp, Facebook, these kind of applications. To develop this kind of applications, we can use application software. For these applications, of best example is Java. Java is an application software. Java is a application software. Let me review yesterday topic here. Java is application software. Okay. Yes. Next here in system software, about OS we have discussed yesterday. So what is OS? OS just it's a platform. OS is a platform where we can run all the application software. See here, like this hardware. Yes, in computer is hardware. On top of hardware, OS. OS will be running here. On top of OS, all the application softwares. Maybe C, C++, Java, Hadoop, all the programs. All application softwares running on top of OS. On top of OS, all are running, right? So here OS acting like a platform. Yes, on top of OS only all are running. So it's a platform. So OS is a platform where we can run all the application software. It's a platform. So what is OS means? Simply it's a platform. It's a platform where we can run all the application software. Okay, fine. Here Java is application software. See, in application software, there are two things: front-end software, back-end software. This is a front-end. Front-end interact with users. Back-end, working at the back-end, it's a server side. Yes, applications and database. Java comes under backend software. See this here, Java, where the Java comes. See here, it's a 1 second. Yeah, here it's a web application. Web application architecture is like this. Here they say front end and back end. Here they say front end and back end. Web application, there are two parts: front end and back end. So these are front end technologies like HTML, CSS, JavaScript. All these are comes under front end. You see at the backend application, maybe Java application or .NET, Python, these applications, right? And then database. So these are backend softwares. So this is front end, this is backend. So Java comes under what here? It's a backend server side. Java is a backend. See, this is client. Here it's a client, this is server. This front end is a client, backend is a server. Front end is client, backend is server. So Java working at the server side to perform server-side transactions. Okay. See here, Java. Java is a backend server-side programming. It's a backend server-side programming. Okay, to develop server-side applications. So Java working at the server side. So Java is a server-side programming. It's a backend. Java is a backend server-side programming. Okay. Yes. See, front-end softwares and backend softwares. Front-end software, back-end software, there are two things like language and packages. So package is a ready-made one, ready to use, no coding. In packages, no coding. For example, MS Office is a package. Yes, in MS Office, no coding. We can prepare documents simply. Next, suppose Tally accounting package. Tally accounting package. Yes, here are no coding. Directly you can use this. These are ready-made one. Package is ready-made one, ready to use. Language. When come to language, yes, it's a programming. We should write the coding here. So you get Java comes under languages. Languages. Java is a language. Yes, in languages, there are two things like high level language, low level language. Okay. High level language and low level languages. Yes, software, languages, low level and high level. So what is low level language? It's a system understandable language in the form of binary code. Okay, here system is processor. It's a processor understandable language. Low level language, it's a binary code. Yes, it's a processor understandable language. Yes, it is called as machine language. The low level language called as machine language. Next, high level language. It's a user understandable language. It is like English language. Easy to understand. See, all these are like Java, C, C++, Python, all the high level language. Okay. So up to this, yesterday we have discussed low level language. So these topics that introduction discussed. Basics of software. Yesterday discussed. Yesterday topic basis. Okay. System software, application software, about OS. Okay. And then, yes, about front end, back end. So about web application, like a client side and server side. Next, language and packages. So next, low level language, high level language. These things have been discussed in yesterday's session. Okay. Yes. Let us start today's topic. Yes, yesterday. Yeah, this is yesterday topic. Yes. See, high level languages, Java, C, C++, HTML, Python, these are all are high level language. So this code looks like English language. Yes, these are high level languages. It's a high level language. For example, Java code. Suppose let us take Java. See, this is Java code, right? Java code looking like English language. It's looking like English language, right? Just it's user understandable language. Okay, suppose let us take some C program. C program. C program. Suppose some C program. See, this is C program. Yeah, this is looking like English language, right? Java program, C program, all they are looking like English language. Easy to understand it, right? Looking like English language, then easy to understand it. Easy to understand. Okay, right? So these are high level language. Java, C, C++, all the high level language, but system cannot understand this high level language. Yes, here system understandable language binary code. Only this language can understand, system can understand only this binary code. But these programs like Java, C, C++, these are like English language, so system cannot understand it. So these programs, Java programs, C programs, C++, all these programs have to convert into binary code. Okay. So this code, that high level language code, Java code, or C code, or C++, or Python. So this code has to convert into binary code here. So which one will convert from high level language to binary code? For this, compilers or interpreter. Either compiler or interpreter. Either compiler or interpreter, yes, converts. So these things converts from high level language. From high level, yes, high level language. Yes, high level language to binary code. High level language to binary code. High level language to binary code. Okay. So either a compiler or interpreter. Yes, either compiler or interpreter converts from high level language to binary code. So compiler, interpreter, both are to convert from high level language to binary code, but some difference. There is a difference here. So what's the difference between compile and interpret? Let us see. So what is the difference? What's the difference? What's the difference between? So what's the difference between, yes, compiler and interpreter here? So what's the difference between compile and interpreter? Yes, you guys anyone idea about it? So what's the difference between interpreter and compiler? Anyone? Anyone, can you tell me? Yes, guys, no one? Anyone have the idea about compilers and interpreters? No idea? Compiler, interpreter. What is the difference between interpreter and compiler? Anyone idea? No idea?
Interpreter does it by line.
Yeah, interpreter is line by line. Okay, Ramesh Patil. Interpreter is line by line. Compiler,
Compiler is a whole program. It will
whole program. Okay, fine. Well and good. Yes, any other difference? Yes, some main difference is there between interpreter and compiler. What's the main difference between interpreter and compiler? Okay, let me explain.
Compiler detects errors while compiling.
Okay,
Whereas if it comes to interpreter, it doesn't go, if it encounters error, it doesn't go beyond it.
yeah. Okay, fine. Well and good. Okay, yeah, let me explain. Yes. So first of all, let us see about interpreter. What is interpreter? Yes, let us see about interpreter. Yes, let us see about interpreter. What is exactly interpreter? Yes, someone compiler will check syntax error. Vikram. Okay, fine. See, let us see about interpreter. For interpreter, I'm taking best example Python script. Python is a interpreter based language. I'm taking some test program, some Python script. Okay, Python script. Let me show some Python script here. Yes. Suppose sample folder. Suppose here, just I'm developing some sample script. D drive, sample folder. Here, I'm developing some script here. Just I'm using Notepad. Just I'm using Notepad to develop the Python script. For Python, actually, we have the PyCharm IDE. Yes, if it is Python application development, you can use PyCharm IDE. But here is a very simple script I'm developing just to explain about interpreter. To explain about interpreter, just I'm using Python script, simple script. Now, command prompt, CMD. First open command prompt at the command. Yes, Notepad using at the command prompt. Yes, go to command prompt at the command prompt. Suppose D colon, that will take to D drive, CLS to clear the screen, DER that shows the contents of D drive. Yeah, this one shows the these are D drive contents. D drive contents. See D drive. Here it's a D drive contents, right? Like MN Rao. Okay. Next GFSG, Tsoft. Yes. Next MN Rao Advanced Java. Yes, C language like frameworks. MN Rao, how do we MN Rao Java? These, right? All these are folders. All these are folders. All these are folders. Next here, these are directories. Folder or directory both are same. No difference. Folder and directory both are same. No difference. See, in command line, yes, in character interface, calling as directory. See, this is character interface. Yes, here, all the commands, just only commands. So it's a character interface. Next here, this is what? GUI, graphical user interface. Yes, it's a GUI. Yes, Windows is a GUI OS. Windows is a GUI operating system. It's a GUI OS. Okay, so here see this. GUI, Windows, GUI. GUI means graphical user interface. Graphical user interface. Graphical user interface. CUI or CLI. Yes, means CUI means yes, CUI means character user interface. Character user interface. CLI means command line interface. It's a command line. Yes, command line. It's a command line interface. Okay. So here this one calling as character interface, CEA or CLI. Okay, anyone both are same here. CEA or CLI. Character user interface or command line interface. Command line interface. Here this one is a command line interface. It's a command line. It's a command line. Yes, here this is graphical user interface. Windows is a graphical interface. So in GUI, these are called as folders. Okay, same thing. Command line is a directory. So folder directory both are same here. Okay. Yes, folder and directory both are same. Both are same. So in GUI calling as folder. In GUI it's a folder. It's a folder. Yes, in character user interface calling as directory. It's a directory. That's it. Now I think it's clear. Folder directory difference is cleared. Okay, in GUI it's a folder. Now D drive. In D drive here this is sample folder. Now at the command line we should go to this folder. Yes, how can you go to this folder? The exit, closing command prompt here. Now first of all opening command prompt. Yes, CMD command, CMD. So this is launching command prompt, CMD, to open command prompt, opened. After opening command prompt, next we should go to D drive, D colon means that will take to D drive. Now CLS to clear the screen. Now we are at D drive, means here we are at D drive, at this location. Now we should go to sample folder. Here it is a sample folder. Yes. So content, you can see this content here, D drive content, DER, D drive content. Now sample directory. Now we should go to sample directory. Tell me guys, anyone, how can you go to the sample directory? How can you go to sample directory? It's very simple. Ramesh.
CD
CD sample, right? CD sample.
Yeah.
CD means change of directory. CD means change of directory. Now changing the sample. Now we are at sample location, sample directory. We are at sample direct location. DER, checking contents. Okay, yes. 0 files. No files here. It's empty. Yes, that sample directory, it's empty. See that sample folder, it's an empty. Sample folder, it's an empty folder. Nothing is there. Okay. Now, here, let us develop one Python script. Now, our topic is about interpreter. Yes, for the interpreter, I'm taking Python. Python script is the best example. So Python is a interpreter based. Okay. Yes. Now I'm using Notepad. So Notepad. Suppose test.py. Right? Do you want to create new file? Say yes. Yes, very simple program I'm developing here. Yes, A is equal to 10. Next, B is equal to 20. Yes, C equal to A plus B, addition, adding two numbers. Now output, printf, yes, addition is equal to, see, displaying C value. Next, C equal to, yes, A minus B. Now subtraction, printf, subtraction is equal to, yes, subtraction, yes, C. Next, C equal to A into B, multiplication, yes, printf multiplication. Right? So this is very simple script. Yes, how this script is working, let us see how it's working. Yes, it's saved, control yes, saved here. Now let us run the script here. So the script dir, check it here, dir, see, test.py. Just now created this file, 2031. That 831 just now, right? Today, just now created this file. Okay. Now, this we can run it directly here. Python test everywhere. Yes, here no errors checking, nothing, directly executing. Yes, script, it's a script, it's interpreter based. If it is interpreter based, it will execute directly. Directly executed. Yes, it's giving some errors. 1 second. Yes, 1 second. Not printf. Printf. Printf, the C language. Printf. Right? See, addition equal 30, subtraction equal -10, multiplication equal 200. So we got the output, right? So executed completely here. Completely executed, we got the output. So A equal to 10, B equal to 20, A plus B 30, A minus B -10, A into B 200, right? Yes, program execute, no errors. Everything is fine. Let us submit once again. Yes, program successfully completed. Suppose any errors, then what happens here? So this case, no errors, successfully completed. Suppose any errors, suppose some mistakes. Suppose here double quotation missing. Suppose here print, yes, that open bracket missing. Okay. Suppose here common double quotation. So these are missing. So there are 3 errors in this, right? There are 3 errors. Control yes, save it. Saved. Yes. Now let us run it once again here. See this. See 7th line error. See, actually there are 3 errors, but here is not showing all the errors. Showing only 1 error. So what happens with the interpreter? Let me explain very clearly how interpreter is working. How interpreter is working. Okay, let us see clearly how that interpreter is working. Suppose, for example, yes, suppose some interpreter based program. Yes, same that Python example, A equal to 10. Yes, B equal to next statement here. Next statement. Okay, the scripting statements. Next statement. So there are some statements in the script here. Next statement. And next statement. Next statement. Suppose Python script is like this. Yes, how interpreter works on the script here. How interpreter works. So first of all, interpreter checks the first statement. Yes, if first statement is correct, then converting into binary codes, then it converts into binary. If statement is correct, then it converts into binary code, serious ones format. This binary code will be given to processor. This binary code given to processor. So processor simply generates output. Simply generates output. Processor simply generates output. Okay. Suppose next statement is also correct. Next statement is also correct. Next statement also correct here. Same thing happens here. Yes, it converts into binary format. Next statement also converts into binary format, like zeros ones format. And then that will be given to processor. That will be given to processor. So processor taking that binary code, simply generating output. That's it here. Okay. Suppose next line. Next line. Suppose something wrong here. What happens? Simply stops. Yes, anything wrong, simply stops. Okay, so here error comes, right? So once error comes, it stops. It won't check for next lines. So Python checking code line by line. First line checking, then executing. Next line checking, then executing. Next line, something wrong, simply stops. Simply stops. Any error comes, simply stops. That means it shows only one error. It shows only one error. Let us see practically. So you get that Python script. Let us see practically here. Yes. In this Python script, see, there are 3 errors, right? So here some double quotation missing. Next here bracket missing. Next here double quotation and comma missing. There are 3 errors. There are 3 errors. So here there are 3 errors. Now here just run it here, but here showing only 7th line. Yes, showing only one error. It's not showing any errors here, any other errors, only one error. That means if any error comes, interpreter stops. Yes, at 7th line itself, stopped here. It is not checking for remaining all the lines. Just checking line by line, any error comes, simply stops. Now let us fix all the errors here. Suppose here I am fixing this error. So this error fixed. Right? Save. So Control S, save it. After saving, now let us submit once again here. See now 11th line error, right? So like this, only one error. Yes, it shows only one error. It shows only one error. That 11th line. So here, right? Here bracket. So this one, right? So this is missing. Save it. Control S, save it. Now submit once again. Submit. Sorry. Yes, again submitting here. I'm submitting again. Yes, see now 15th line error, right? 15th line error. 15th line. Now let us correct this error here. So this here is error, right? Yes, done. Now here. Now let us submit here. One second. Yes, let us submit. Yes, executed successfully. Yeah, this is working of interpreter. Yes, interpreter checks the code line by line. If any error comes, stops. It checks the code line by line. It checks the code line, checking first line, checking next line, checking next. Something wrong here, simply it stops. So interpreter shows only one error. Interpreter shows only one error. Okay, so this is working of interpreter. Now let us see about compiler. How compile is working. Yes, compile also we'll see practically one example here. How compile is working. Yes, for compiler, I'm taking C program. For compiler, I'm taking C program. Compiler. Compiler. Yes, I'm taking some C program. Suppose test.c, C or CPP, anyone. Suppose test.c program. Yes, if it is compiler, how it's working here. Compiler checking first line. Suppose first line is correct. C program first statement is correct. Yes, even statement is correct. It won't convert into binary code immediately. No, no, it won't convert into binary code. It won't convert into binary code. Even statement is correct. Yes, immediately it won't convert into binary code. Then checking for second statement. Suppose if it is correct, then third statement. Suppose something wrong at third statement, then compiler shows that error at third line. After that, it will check for next line also. It check for next statement. So next statement like this top to bottom. Compiler checks the whole program from top to bottom and shows all the errors. Suppose here also some error. It shows this error. Okay, next error, next error. It shows all the errors. So compiler checks the whole program from top to bottom. Compiler checks whole program from top to bottom and shows all the errors. Interpreter is only one error. Any error comes, any error comes, simply interpreter stops. Any error, interpreter stops. But compiler is not like that here. Compiler checks the whole code from top to bottom and shows all the errors. All the errors. Okay, all the errors. Yeah, let me show compiler example here. Yes, for this I'm taking C program. For compiler, yes, C program, turbo C. C program, here, see, here already prepared program is available. Here, this is a C program. Same example. That ABC, three variables declared here. Yes, reading first number, second number. Yes, C equal to A plus B, C equal to A minus B, C equal to A into B. So addition, subtraction, multiplication of two numbers. Okay. C compiling. Yes, success. No errors. No errors. Now run the program. Yes, running, right? Yes. First number, let us say 10. Second number 20, right? Yes, addition, subtraction, multiplication, got it. Suppose any errors, what happens? Let us see. So here any errors, what happens? Let us see. Suppose here semicolon missing. Suppose here bracket missing. Okay, suppose here comma missing. Okay, here some semicolon missing. Okay, here some double quotation missing. Okay, suppose here semicolon missing. Suppose here some bracket missing. Right? Now save it. Saved. After saving, now I'm compiling. See that the errors, right? Total there are 9 errors. 9 errors. Press any key. Press any key. 9 errors. See that? So you can look at the bottom. 9th line error. 11th line error. 15th line. 21st line. 23rd line. 25th line. 27th line. 29th line. 33, right? All the errors from top to bottom. Compiler shows all the errors from top to bottom. Compiler shows all the errors from top to bottom. Right? Yes. Now, let us fix the errors here. These errors. Let me fix all these errors here. All these errors. Okay. Now, save. Saved, yes. Overwrite, yes. Now again compilation. So still some more errors. So still some. So 4 errors. There are 4 errors. Some more errors. Here comma missing. Okay, next here semicolon missing. Okay, again I'm saving here. Save. Yes, overwrite, yes. Now again compilation. Recompilation. Yes, still 2 more errors. 2 more errors, right? So here semicolon missing. Next here bracket missing. Here bracket missing. Now, yes, save it. Saved. Yes, say yes, overwriting. After overwriting, now compilation, compile. Yes, success, right? Now run it. Yes, getting output. So 10, 20. So output got it, right? So how compiler working here? Compiler checks the whole program from top to bottom. Compiler, yes. Compiler checks whole program from top to bottom. Yes, compiler checks whole program from top to bottom and shows all the errors from top to bottom. Suppose if no errors, then what happens here? After fixing errors, recompilation. After fixing errors, just recompilation. Suppose if no errors, then what happens here? How it works here? Suppose everything is fine. If everything is fine, then how it works? In that case here, compiler opens another file. It opens another file. Compiler opens another file here. Yes, compiler checks the whole code from top to bottom. Suppose if no errors, now compiler converts this whole code into binary format. Whole first line into binary format. Next line, next statement into binary code. Next statement into binary code here. So next statement into binary code. So next statement binary format like this. Every line top to bottom. Compiler converts whole code from top to bottom into binary code and write to another file. Yeah, this file is called as exe file. The test.exe file generates. It generates test.exe file. It generates one test.exe file. So compiler checks the whole code from top to bottom. So compiler checks the whole code from top to bottom. If no errors, generating one exe file. That exe file submitted to processor. So submitted to processor. Submitted to processor. So processor takes that code and generates output simply. So this is working of compiler. Yes, let me show this exe file. Test.exe. Let me show that. See, this is your program. Yes, test.cpp. CPP means C++. C++ and C language. Same compile. Here CPP compile using for the both here. C++ compile using for the both. Now, test.cpp. Let me show that backend. C drive. So TC folder. It's a bin folder. So this is test.cpp. Okay, see this. 2043. Yes. Time of modification, just modified. Yes, 6th February 2040, just modified. Yes, open with notepad. So this is your C program, right? This is C program. So this is your C program. Back and right. Okay. Yes, that related programs I'm deleting here. That related programs I'm deleting. So test it. So you can see this test.cpp. Only one file is there, test.cpp. Now let me compile. Compile success. Success, right? Now I'm running. So when I try to run it here, so before going to running, it will create one exe file. Just observe here exe file. Just I will try to run. When I try to run here, it creates one exe file. Run it. See that here at the bottom, exe file created. Yes, 1 second. Refresh. See the test.exe file. So here this is right. Just now create application means exe file. Just now created 2047. Just now created. Okay, let me show the properties. Properties. See .exe rate. .exe file created. Test.exe file created. After creating exe file, then executes. Exe file created, now executed, right? Executed. See that? Yes. See the exe file created and executed. So enter first number 10, next number 20. So getting output, right? So this is what is happening with the compiler. What is happening with the compiler? So compiler checking whole code from top to bottom and shows all the errors. It shows all the errors. Suppose you don't have any errors, simply this program test.c file, that source code. This is source code. Yeah, this code is called a source code. Yes, that whatever program we are writing, our code is a source code. Simply this code simply converts into binary code. So compiler checking whole program, if no errors, then converting into binary format. Converting into binary format generates one exe file. That exe file submitted to processor. So processor executes that whole exe file at a time, generating output. So this is difference between interpreter and compiler. Now tell me guys, what do you observed? Main difference between interpreter and compiler? So what's the main difference between interpreter and compiler? Yes, anyone? Can you answer this? What's the main difference observed here? So what is the main difference observed between compiler and interpreter? Yes, anyone? So what is
Translate the code from the high level to the low level.
Yeah, both are high level to low level, but some difference, some main difference. One difference observed, very clear difference observed. What is that clear difference here?
Compiler compiles the whole code irrespective of if it finds any code to be wrong. Whereas when it comes to interpreter, it stops immediately once it's found it encounters any error.
That is your old answer. Same old answer, just you repeating.
Oh, so that is
Yeah.
not the major difference?
Yeah, main difference. What is the main difference? See the these two pages. Interpreter explanation, right?
Yes.
This one interpreter explanation. This one compile explanation. What's the difference observed?
Interpreter stops actually once.
That is already old. Your old answer. What's the new thing observed in this?
exe file.
Yeah, exactly.
Printable file. Yeah.
exe file is a difference. Okay. Yes, generally no trainer will explain about exe file. Simply they will explain about what is compiler, what is, but behind of this is exe file. Exe file generates. Compiler generates exe file. Interpreter reverse generates exe file. Now let us see points wise. Yes, interpreter versus compare the differences. Let us see comparison. Yes, interpreter, let me explain points wise. Yes, interpreter compiler. Let us see comparison. The different interpreter and next compiler. Interpreter compare. Yes, in the first difference. Yes, it checks the code. It checks the code line by line. line by line, right? Yes, compiler. Yes, it checks the code. Yes, it checks whole code from top to bottom. From top to bottom. It checks whole code from top to bottom, right? Yes, next difference here. See, interpreter checking line by line. Suppose any error comes, simply stops. Okay. So if any error, yes, interpreter stops. It stops. It stops, right? Stops. So it shows only one error. It shows only one error. Only one error. Only one error. Right? Yes, compiler. Yes, it checks the complete code, whole code from top to bottom. So it shows all errors. It shows all errors. All errors in the program. All errors, right? Yes, here main difference, exe file. Main difference exe file. See, interpreter, it does not generate exe file. It does not generate. It does not generate exe file. It does not generate exe file. Compiler, it generates exe file. It generates exe. This is main difference between interpreter and compiler. So interpreter, it does not generate exe file. Compiler generates exe file. Okay, right? Yes.
Interpreter generate which file?
Interpreter does not generate no exe file with the interpreter. Compiler generates exe file. See, in case of interpreter, yes, that source code executes directly. Test.py, the script file. Source code executes directly. It won't generate any result file. It won't generate any result file. Simply directly source code executes. Test.py is your source code. So this is your source code. See, here this is source code. This source code executing directly here. Interpreter executes source code directly. It won't generate any result file. No another file. Only one file. Only one source file here. Okay. So interpreter does not generate exe file. Yes, it executes. It executes source code directly. It executes source code directly. If any error comes in source code, simply stops. Okay. So interpreter, without checking any errors, directly executing. Interpreter executes the code directly without checking any errors. But in case of compiler, what happens here? First of all, checking for all the errors. If no errors, generating exe file, then executing. So here it executes exe file. It executes exe file. I hope you understand, right? Yes, interpreter, it does not generate exe file. It executes source code directly. Yes, whereas compiler, it generates exe file and it executes exe file. Yes, I hope you understand, right? So these are differences, interpreter and compiler. Next, one more thing here, interpreter-based languages. Interpreter-based languages are called as scripting languages, scripting. So these are called as scripting languages. Compiler based languages are called as what? Anyone idea? Interpreter based language is scripting language. Compiler based is a? Anyone? Interpreter based language are scripting language. For example, Python is the interpreter based. So Python is a scripting language. Suppose HTML is also scripting language because of interpreter based language. Yes, compiler based languages are called as what here? So these are called as programming languages. Programming languages and scripting language both are not same, different. Programming languages. So compiler based, these are programming languages. So interpreter based languages are scripting languages. Compiler based are programming languages. Yes, scripting language examples. Yes, what is an example of interpreter based language? Python. Python is the best example of interpreter based language. Any other examples? Guys?
JavaScript. JavaScripting.
Yeah, JavaScript is also interpreter based language. Next, HTML. HTML is also interpreter based language. So Python, yes, HTML, JavaScript. See, for Python,
shell scripting.
yeah, exactly. Linux shell scripting. Yes, in Linux there is shell script, right? Shell script is also interpreter-based language. Next, any other examples? PHP, also interpreter-based language, like Perl scripting. These all are interpreter-based languages. See, for Python, Python interpreter is there. HTML. So what is HTML? HTML stands for what? HTML stands for anyone? I think you know this one.
Hypertext markup.
Yeah, exactly. Hypertext markup language. Yes. What is interpreter for the HTML? Tell me. What is an interpreter for the HTML?
Its
So
own
which one?
browser,
Which one?
web browser.
Yeah, browser, exactly. Browser is an interpreter for the HTML. Yes, HTML is a browser understandable language. HTML is a browser understandable language, like this kind of browsers. Okay, maybe Google Chrome browser or Firefox, whatever that browsers. It's a browser understandable language. HTML is a browser understandable language. Browser is an interpreter for the HTML. Next, JavaScript. JavaScript is also same browser understandable language. Yes, for JavaScript, yes, browser is an interpreter. See, JavaScript and Java both are not same. Java different, JavaScript is different. Let me explain differences here. JavaScript and Java. JavaScript and Java difference. See, here in application, there is a front end, back end, right? See here, JavaScript here comes. JavaScript is a front end using at the client side. JavaScript is a client side script for client side validation. JavaScript using at the client side. It's a browser understandable language. JavaScript is a client side program, client side scripting. It's a browser understandable language. It's interpreter based. JavaScript is a interpreter based language. It works at the client side. Yes, it works at the client side. What is Java? Java is a server side programming. Java is a server side. JavaScript working at the client side. JavaScript at the client side, Java at the server side. JavaScript is a browser understandable language. Java is a JVM understandable language. So JavaScript and Java both are not same. It's a different. JavaScript is different, Java is different. So JavaScript is a interpreter based language and working at the client side. Java working at the server side. That's the difference. So JavaScript is at the client side, Java is at the server side. Okay, fine. Okay, and next, shell scripting. For the shell is an interpreter. In shell script, there is a shell. PHP having its own interpreter. Perl is having its own interpreter. So these are, yes, interpreter scripting languages. All these are scripting languages. Okay, yes. Compiler based examples. Programming language. Tell me, guys. Compiler based example. Just now we have discussed it.
C, C++, Java.
C and C++. C and C++, right? C and C++. Next one more. .NET. .NET C Sharp. .NET C Sharp. So these are compiler based. C and C++, next .NET C Sharp is a compiler. These are programming languages. These are the examples of, yes, programming languages are compiler based. These are compiler based. These are interpreter based. Okay. Yes. Let us come to some conclusion here. Some conclusion. Yes, interpreter. Yes, interpreter based languages don't have exe file concept, don't have exe file concept. Here don't have exe file concept. Yes, in compiler, yes, every time exe generates. With compiler, finally exe generates. Exe file generates and executes. Yes, always it's a exe file. Exe file generates. Finally, exe file generates. Okay. Yes, interpreter based language don't have the exe file. Interpreter based languages don't have exe file. With compiler, always generating exe file. Okay, with compiler, always here it's exe file. Interpreter don't have exe file. Okay. Now, let us come to actual topic. Maybe you guys getting some doubt. See here, I'm explaining all of these things, right? Many things. I'm talking about many things, but where is Java? I'm not talking about Java, right?
Yeah.
Now let us see Java. So what is Java about Java? So what is Java? Yes, is it compiler based or interpreter based? Java, compiler based or interpreter based? Anyone? Anyone idea about it? Java, compiler based or interpreter based?
Yes, compiler.
Compiler based. So we saying yes, Sahiba saying compiler based. Next others, yes, Fatima compiler based. Next any others? Any others? Mr. Lokesh, what is Java? Interpreter based or compiler based? What is Java exactly? Okay, let me explain about Java. Yes, first of all, I'll explain about Java, then you answer that. First, I'll explain about how Java is working. I'll explain very clearly, then you answer. Okay. Yes, let us see about Java. Except Java. In other languages, what happens here? Maybe programming language or scripting language. Except Java. In other language, maybe C programming or C++ or Python scripting, shell scripting. What happens? Let us see. Yes, source code. First of all, source code converts into binary code. Source code converts into binary code. Yes, maybe Python scripting or C program or C++, any case. So first of all, source code. Source code means your program. This is called a source code. Yes, it's a source code, your program, source code. Simply converts into binary code. That conversion may be either compiler or interpreter. Converting into binary code, that binary code simply it will be given to processor. It will be given to processor. So processor taking that code, generating output. This is what is happening with other languages. With other languages. Now let us see with Java. So with Java, what happens here? Yes, in Java, source code. First of all, source code. Source code simply converts into what here? Byte code. Here there is a byte code. Byte code, that byte code converts into binary code. Binary code. Binary code. That binary code given to processor. That binary code submitted to processor. Processor. And then, yes, processor executes generating output finally. So this is what is happening in Java here. Yes, in Java, there are two steps. First, source code converts into byte code. Next, byte code converts into binary code. In other cases, only one step. Source code directly converts into byte code. In other languages, source code directly converts into binary code, means system understandable language, and executes. But in Java, what happens? There is an intermediate code. Byte code introduced here. So first of all, source code converts into byte code to binary code, that binary code given to processor, finally generating output. So why this byte code introduced in Java? Here there are two steps. In Java, two steps. So byte code. So why byte code introduced in Java? Byte code was introduced to make Java as independent platform. To make Java as an independent platform. Independent. Yes, independent of platform. Yes, what is exactly independent of platform? Next we'll discuss. Wait for some time. So wait for, I think tomorrow or day after tomorrow getting the topic. How Java made us independent of platform. Java is independent of platform. That is next class topic. In next class, we can see that. Okay. Yes. In Java, bytecode was introduced to make, yes, to make Java as independent of platform. Okay. Let me show Java example also. Let us take Java example. Java example. Yes. Java example D drive. Yeah, here are same. Let us take same folder, sample folder. Let us take same folder, CMD, command prompt. Command prompt. Yes, next D:D drive, CLS to clear the screen. So DER. Now here's a sample directory. CD sample changed, CLS screen cleared. D here, right? Now let us write one simple Java program. Here actually for Java program, yes, we are going to use Eclipse actually. Okay. So going forward, I'll be using Eclipse only here, not using Notepad. Just only one example today I'm explaining Notepad. So next coming classes, completely with Eclipse only. Java we are running in Eclipse always. Yes, let us see very simple program. Some Java program, Notepad, suppose sample.java, Notepad sample.java. Yes. Do you want to create new file? Say yes. Now let us write simple Java program. Public class sample. Yes, class starting, ending. Next year, public static void main string array of args. See, our topic is not about Java program. Our topic is about comparison interpreters. About this program later I'll explain what is public, what is class, what is sample, what is static void, and all that later we'll see. Once we enter into Java, that time I'll explain. Our topic is not about Java programming. Our topic simply how it's working. Just I'm explaining about comparison interpreters, not Java program. About Java program, next we'll discuss. Just wait for some time. Yes, system dot, yes, out dot, yes, println. Println. Yes, here is a hello world. Simple program, hello world program. Hello world. Saved. Control yes, saved. After saving, now go to here. Here, see that? That sample.java just now developed, right? Today, 21 minutes. So 9 o'clock, 8 minutes. Just now. So this is developed. CLS. Okay, sample.java. Okay, DR sample.java. Yes, it's a source file. Sample.java, it's a source. Yes, this is source code, Java source code. So this is that English language code is a source. It's a source like C programming. See, this is C programming source, right? It's a C program source. It's a C program source, right? Next, see here, this is Java program source. Java program source code. Just is a source code. Okay. So here, the program developed here. Now, first of all, you have to compile it here. Like C programming, here also you have to compile it. Directly can't execute. Here you have to compile it. Like C programming, yes, here also you have to compile it. Java sim Java compiler. Compiled, no errors, no errors. Then output dot plus file generated. Yes, result file is dotless. Suppose C programming, result file is exe file. C compiler result is what? Exe file. Java compiler result is what? Dotless. So what is this dotless file? Here dotless file contains byte code. It is not a binary code, just it's a byte code. It's a byte code. It's a byte code. So what is happening here? See, yes, that sample.java. Sample.java. It's a source code, right? Sample.java is a source code. Yes, this source code given to submitted to Java compiler, taken by Java compiler. Java C means Java compiler. The test sample.java, it's a source code taken by Java compiler. Then compiling program from top to bottom, it's a compiler, Java compiler. Compiler checks the whole code from top to bottom. So Java compiler checking whole code from top to bottom. Yes, if no errors, then generating sample.plus file. Generating sample.plus. Sample.plus is a bytecode file. It's a bytecode. Bytecode generates. Now bytecode is ready, right? The dot plus file is ready. Now you have to run it. Java, yes. Sample. Java sample dot plus extension is not necessary to run it here. Java sample, yes, execute, right? So here Java C means so first step compilation process. See DR that sample.java file. Java C sample dot Java. So first step compilation. After compilation result is dot class file. That source code converted to dot class file. Okay, so you get source code sample dot Java file. Source code file taken with Java compiler, checking from top to bottom. If no errors, generated dot class file, bytecode file generated. Now this bytecode file, now I'm executing Java. This is sample. I'm executing, right? Yes, executed. What is this Java? So you get Java C means it's a compiler. Here Java means what? It's an interpreter. It's an interpreter. Okay. So here this is compile. Java C is a compiler. Java is a interpreter. The dot class file taken by the interpreter. Dot class file taken by the interpreter. Okay. The dot class file taken by the Java interpreter. It's interpreter. It's an interpreter here. Interpreter, right? Taken by interpreter. Interpreter, right? Yes. Now interpreter converting bytecode to binary code. It converts bytecode to binary code. Binary code. After converting into binary code, that binary code given to processor. See here, when you come to interpret Java interpreter, line by line conversion. Converting bytecode to binary code line by line. First line converts, executes. Next line converts, executes. Next line converts, executes. Given to processor, then executing, right? So finally generating outputs. Okay. So here interpreter, Java interpreter directly running that code, right? Bytecode running by the Java interpreter directly executes and generating output. So here are no exe file. Here no exe file generated here. Okay. So you get Java compiler, yes, converting from source code to bytecode. Bytecode to binary code by the yes interpreter. Okay. Yes. See first part, source code to bytecode. Source code to bytecode. So this part, source code to bytecode by the Java compiler. So this is by the Java compiler. Source code to bytecode by the Java compiler. Next, second part. Second part, bytecode to binary code. Bytecode to binary code. Bytecode to binary code. So this is by the Java interpreter. By the Java interpreter, right? By the Java interpreter. Right? Interpreter. So finally we are getting result. Okay, result, right? So initially Java compile involving, later at runtime interpreter involving. Now tell me, so what is Java? Now Java depending on compiler, interpreter, both are. Yes, come to some conclusion. Java, is it compiler based or interpreter based or both?
Both.
Both.
It's a both. So Java depending on both here. So Java depends on both compiler as well as interpreter. It's depending on both here, compiler as well as interpreter. Okay, Java depending on both the compiler as well as interpreter. Okay. Yes, simply don't say Java is a compiler based language or interpreter based language. No. Java depending on both. Java is a compiler. Java is a, yes, depends on both compiler as well as interpreter. So Java, yeah, depending on both the compiler as well as interpreter. Both here, both are involving in Java, compiler and interpreter. Compiler checking for errors. Program executing by the interpreter. Okay. So in Java, see, in Java, errors checking by the errors checking by the compiler, compiler. Yes, next program execution means running program execution by the interpreter, program execution by the interpreter. That's it. There are two things involving here. Okay, there are two things involving. Yes, here some question for you guys. Some question. Can we create exe file in Java? Yes, what you observed here? Yes, have you observed anywhere exe file in Java? See, sample.java file converted into dot class file, right, and executed. Have you observed any .exe file here?
No one.
Yes, any .exe file? No, no .exe file. Okay. So can we create exe file in Java? No. Yes, is a interview question. Interview question. Can we create exe file in Java? No. Exe file cannot. We can't create. Yes, no concept of exe files in Java. Okay. No concept of. Yes, no concept of exe files in Java. Exe file in Java. Java don't have exe file concept. Java don't have exe file concept. So why exe file concept eliminate from Java? Yes, Java here compiler working, but generating dot class file. Why not exe file? So why exe file? Yes, exe file. Why exe file? Why exe file concept removed from Java? Yes, exe file concept was eliminated. Eliminated. So why? Exe file concept was eliminated from Java. From Java, yes, to make it as independent of platform. To make it as independent of platform. Independent of platform. To make it as independent of platform. Okay. See, exe file is a platform dependent or OS dependent. Exe file is a OS dependent, platform dependent, but Java is a independent of platform. Yes, to make Java as independent of platform, to make it as independent of platform, that exe file concept removed. In place of exe file, here is a dot class file, bytecode file. That bytecode was introduced here. Yes, bytecode introduced to make the Java as independent of platform. Bytecode introduced to make the Java as independent of platform. The dot class file in place of exe dot class file, yes, came to picture. So dot class file introduced to make the Java as independent of platform. Yes, the topic next we'll discuss. How Java made us independent of platform. Next coming topic. In the next classes, we'll discuss that. Okay. Yes. So exe file is different. Dot class file is different here. So in Java, everything is dot class file. Java, everything is a dot class file. See, dot class file is not an exe file. Dot class is not an exe file. Exe file is different. Dot class file is different here. See, exe file is a binary code file. See, exe file is a binary code. It's a binary code file. Exe file is a binary code file. Okay. So whereas dot class file is a dot class file is a bytecode file. Bytecode file. Dot class is a bytecode file. Next, exe file. See, exe file. Yes, exe file is a system understandable language. Exe file is a system understandable. Yes, system can understand exe code directly. That exe code, binary code, system can understand directly here. Exe file is system understandable language. Exe file code is a system understandable language here. Okay. Yes. So whereas bytecode file, that dot class file means bytecode. Dot class is bytecode. Bytecode is a JVM understandable language. JVM understandable. So exe file is a system understandable. Dot class file is a JVM understandable language. JVM understandable language. JVM understandable language. Next, one more difference here. Exe file is a platform dependent. Exe file is a platform dependent. Platform dependent. Platform dependent. Platform dependent. Yes, what is dot class file? Dot class file is a independent of platform. Dot class file. Dot class file is an independent of platform. Independent of platform. Dot class file is an independent of platform. Okay. See more about exe file and dot class file. We'll see next time. Yes, dot class file is an independent of platform. It's an independent of platform. Yes. How it's independent of platform? Next coming topic. Yes, there are many differences between exe file dot class file. Yes, most important topic that exe file dot class file differences. I think in next class getting this is okay. So this is about Java introduction. Just Java introduced. Java introduced from next class onwards. Yes, we are going to discuss about Java only here. So next session, how to install Java, how to install Eclipse here, how to write the first program, and then Java features we'll discuss. Okay. So today's topic, let me repeat today's topic. See your document. So this is document. Today's topic document. So interpreter compare the differences. Interpreter and compiler. Interpreter and compiler. The differences. Very clearly explain document. But all the points I have prepared. This document I'll share with you. Yes, about Java. Java depends on both compiler as well as interpreter. See that. Same that explanation. Source code to byte code to binary code, processor, then output here. See, source code to byte code was Java compiler. Byte code to binary code was Java interpreter. See the different stages, different steps here. Okay, so bytecode was introduced to make the Java as independent platform. Java depending on both compiler as well as interpreter. Java depending on both compiler as well as interpreter. Okay. Yes. See, can we create exe file in Java? No. There is no concept of exe files in Java. In Java, everything is dot class file. But dot class is not an exe file. Okay. Exe file is a binary code file and it's a processor understandable language. Next, dot class file is a byte code file. It's a JVM understandable language. Exe file is OS dependent. Dot class file is independent of OS. See, exe file dot class the difference. There are many differences. Exe file dot. So next class topic difference between exe file dot class file. Okay. So next session we will discuss. Yeah, that's all about Java introduction. Okay. So that's all for today. Yes, any doubts, guys? Yeah, this document I'll share with you. No worry about it. Document here, I'll share with you. Yes, Google Drive. Yes, today after finishing class, I'll give the Google Drive access. That Google Drive access will be given to all paid students only, not for all whoever paid. Okay, for them, Google Drive access will be given. In Drive, you can see all recordings, day 1 to today. Day 1, when your batch started, Monday. So Monday, Tuesday, Wednesday, Thursday. These 4 sessions you can see in Google Drive. For all paid students, that Google Drive access will be given immediately today night itself. Right? Yes, in Google Drive, you can see recordings as well as this class document, both class document, recordings, and next Java software and Eclipse software. In Google Drive, you can see recordings, next this PDF, and next Java software and Eclipse software. Everything through the Google Drive will be shared. That will be shared your Gmail ID. See, any paid students share your Gmail ID to online team. Yeah, they will provide the access. Okay, online team will give the access immediately here. Okay, all recordings, documentation, software, everything is available in the Google Drive. We'll share through the Google Drive. Right? Yeah. Yes, any doubts, guys? Still any doubts? No doubts, right? Hello? Any doubts?
No doubt, sir.
No doubts, right?
I wanted
Yeah,
to
1
check.
second. No doubts, right? Yeah. 1 second. Just a minute. Just wait for a minute.